Hi, hello. This is Satish Kumar M, Assistant Professor, Department of Agriculture Engineering, Kongnadu College of Engineering and Technology, Tottiyam, Tiruchi. Today, we are going to discuss about conduct equilibrium separation process and extraction process. Okay. First, we have to go into equilibrium separation process. Okay. First, we have to know what is equilibrium. Equilibrium is a state or rest or balanced due to the equal action of opposing two forces. Okay, it is the state of balance between two opposing forces or actions that is either static means as in a body acted by the force resultant in zero, or dynamic. Okay, dynamic means as in reversible chemical reactions when the rates of reaction both directions are equal. That means in this picture clearly explain the equilibrium process. Okay, first the solution containing a more number of solid particles. Second, water does not having any solid particles or any particles. The particles slowly waters enter into the unsolid waters at the some point of process. In the entering of solids into the water will be completely stopped. That point will be considered as equilibrium. There is attaining the equilibrium point. There is no exchange of solid particles from this phase to this phase. Okay, the transformation will be stopped, or one particles will be transferred into the this phase. In one particles transfer into the this phase. Then the exchange of particles will be same at the time of equilibrium point. Okay, equilibrium point. Once equilibrium point develops, in the concentration of liquids or particular solution does not differ. Okay, there are different types of equilibrium are there. First one chemical equilibrium, second one dynamic equilibrium, and then fourth one ionic equilibrium. These are the types of equilibrium. In the case of chemical equilibrium, the reverse reaction and forward reaction will be zero in the equilibrium point of reactions, or once equilibrium point is reached, the forward reaction reverse reaction will be nil. Okay. Yeah, definitions of conduct equilibrium separations. A conduct equilibrium separation process is designed to reduce the concentration of particular component in one phase or flowing through stream in a continuous process and increasing it in another. Conventionally, and just to distinguish one stream from the another. One is called the overflow and then other the underflow. This is called the conduct equilibrium process. The phase transformation of equilibrium. Examples of solid liquid equilibrium, and then examples of liquid gas equilibriums, and then solid vapor equilibrium. In the case of solid liquid equilibrium, the H2O solid will be transferred into H2O liquids at the time of equilibrium point. The transformation will be zero. The transfer of H2O solid into liquid, it will be zero. Next one, liquid gas equilibrium. H2O liquid transfer into the H2O gas in at the point of equilibrium. The transfer of liquid and then transfer of liquid into gas and the transfer of gas into liquid will be same or zero at the time of equilibrium. Okay, let's move into the solid vapor equilibrium. So I2, and then I2 and I2 solid particles transfer into I2 vapor particles. At the point of equilibrium point, the I2 solid particles transfer into vapor particles. I2 vapor particles transfer into I2 particles is zero or equal at the point of equilibrium point. Okay, and the examples of solid liquid equilibrium: rate of melting equal to rate of freezing of water. Okay, in the examples of liquid gas equilibrium, the rate of evaporation and the rate of condensation is same at the point of liquid gas or gas liquid equilibrium. The rate of sublimation and the rate of deposition is equal at the point of solid vapor equilibrium. This is the basic concepts of equilibrium. Next, we are going to discuss about the extraction process. Okay, extraction process. Okay, extraction is defined as removal of soluble constituents from a solid or a liquid or semi-solid with means of suitable solvent. Okay, extraction is defined as removal of soluble constituents from solid or liquid or semi-solids with means of suitable solvents. Okay, it is defined as the treatment of plant or animal tissues with the solvent whereby the mechanically active constituents are dissolved and most of the inert matters remains dissolved. Okay, the solvent used for extraction is known as menstruum. The inert soluble materials that remains after the extraction is called MAC. Okay, MAC. Okay. This picture shows simply the distillation process. Sorry, and the extraction process. The extraction process. The solids having main particles. In the leaf having the important constituents. The leaf will be um, submerged into the particular solvent. The particular solvent, in the particular extracting the main constituent of leaf. After the extraction, the solvent materials having the constituents of leaves. Okay, this is the extraction process. Okay, the leaf will be submerged into the suitable solvent. The solvent is extract the main principle from the leaf. After the extraction process, the main principles are deposited in the particular solvents. Okay, after the extraction, the solvent going to be distillation process. Due to the distillation process, in the solvent and then active principles will be separated in the case of distillation process. Okay, this is the liquid extraction. This in this picture shows liquid extraction. In this beaker, two submergible or immersible solids are there. Due to mixing process and due to mergeable solids are measured into the or converted into the single solvent. After the settling process, and the solvent will be equally distributed into the two different solids. So two different liquid particles, liquid phases. Once the liquid phases extracted into the different types. Okay. A supercritical fluid is a material that can be either liquid or gases used in the state above the critical temperature and the critical pressure where gases and liquid can be coexist. Okay, the extraction methods and different types of extraction methods are there: infusions, decoctions, digestions, percolation, and macerations. Okay, infusions. In the case of infusion, the plant material is dipped into the or mixed into the particular solvents. Or the decantation. Next decantation. Decantation is one of the extraction process due to the heat transfer. Okay. Next one, digestion. In this form of maceration in which gentle heat is used to process or extracting the particular solvents. It is used to in moderately elevated temperature. It is not objectionable. The solvent efficiency of menstruum is thereby increased. This image shows microwave digestion systems. Okay. Next one, maceration. In the process of maceration is extraction of solvents from extraction of active solvents from particular plant materials. The flow chart of maceration are the basic procedure to macerations. Okay, we have to take 100 gram of dye powder, add 500 ml of ethanol, keep 4 hours with continuous shaking or magnetic stirrers. After pouring into the filters, and the residue will be collected, add 500 ml of ethanol into residues, keep 4 hours to continue shaking. Again, you have pour into the filter, and then residue will be collected, added into 500 ml of ethanol. Again, keep overnight for the continuous checking. Again, you have to entering into the filter process. Residue will be collected and pull the all the filters. Okay, pull the all the filters. Pull the all the filters means we have having three filters. After the gaining three filters, the three filters are mixed into one solutions. Okay, they added into pulled into all the filters into the one solutions. It is having a equal amount of active constituents extracted from the dry powders. Okay, or the next one, filter percolation. The process of percolation is explained through these images. Okay, finally chopped plant matter mixed into the solvent. Second point, the solid residues are pressed into the recover and remaining liquids, filtered through the furnace, strained and the express the liquids are mixed in the clarified. This is the evaporation process. The fact is controlling extraction process, area of contact between the streams, time of contact, properties of material, number of contact stage or employment. These are all the factors influencing the extraction process. And the rate of extraction is calculated by using following formula. The rate of extraction equal to driving force divided by resistance. Okay, this is the important formula to calculate the rate of extraction. The Boltzmann extraction is the perfect example of example for solid liquid extraction process. Door agitated is the perfect example of liquid extraction process. Decondension systems are example for um, liquid solvent extraction process. Column extraction and tower extraction is the other type of extractor. After the extracting process, we are moving into the washing process. Cleaning and washing is the unit operation is the which contaminating materials are removed from the food and separated to leave the surface of the food and suitable condition for the further processing. Okay, this extraction and washing processes followed by distillation process. The distillation process will be discussed in the next presentations. Thank you.